All right, for the warm-up, we need to know a sub 1. What's a sub 1? 27, good. Good morning. All right, a sub 1 is 27, very good. How about D? How much is D?
D is 69.
How much for this one?
Oh, -7.
-7?
Yeah.
Okay. So if you're not sure about D, it's the amount you're adding each time. And since it's going down, it is a negative number. One easy way to do it is Blaine used the terms a sub 2 minus a sub 1. You could just subtract the second minus the first. And you can get that your D is -7. All right, good morning. Raise your hand if you are ready to share the rule. Go ahead, Sky. Good. All right, did you guys get the same rule that Sky got? So here's the first term, right? And we're going to add -7, not n times, but 1 less than n times, right? So to find the second term, you're adding n once. To find the third term, you're adding n twice, right? We figured that out last class. And we have a formal rule on our notes from last class as well. Okay, so now we have to use this rule to find the 50th term. So I would put 50 for which variable? For n. Good, 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 good. All right, so a sub 50, 27 plus 50 minus 1 times -7. If you haven't found that yet, please find that now. I'm going to be looking for 3 answers to make sure we confirm we got it, okay? All right, anybody have the answer already? Yeah. Josiah, what'd you get? -316, and Alec is agreeing, and Sky is agreeing? Okay, very good. Gideon, did you also agree? Thank you. All right, so your 50th term was -316. All right, so last class we talked about these adding patterns. Even when the number is decreasing, we still consider it an adding pattern because we're adding a negative. Today we're going to be talking about a multiplying pattern. And in the previous one, we added D. We're going to be multiplying by R. R is called the common ratio. It's just the number that you multiply by each time. And if R is greater than 1, then your number will be getting bigger each time. R could also be a fraction, like 1/2, and that could make your number decrease each time. Notice the formula is written 2 different ways. What's different about the formulas? Not much, right? Just which 2 letters are switched? A and U. So this is how IB writes it. If you're going to take an IB class next year, and you're like, where did this U come from? Just what they use instead of A, okay? It's not a big deal. So if you take an IB class next year and the formulas look unfamiliar, they're not new formulas. They're just like a different way of writing it. You know, just like how like different languages have different words for things. All right, what are we doing here? So we have a formula to find the nth term. So for example, to find the 5th term in a geometric sequence, I would take my first term and I would multiply it by R. Now the number of times I multiply it by R is 1 less than n. Just like in the other pattern, the number of times we added was 1 less than n, it's the same thing here. The reason why n minus 1 is the exponent is because if I have R to that power, say R to the 4th, then that just means times R times R times R times R. So instead of writing times R 4 times, you just use the exponent. All right. So in example 1, we're going to try to find the common ratio. That's the number we multiply by. And in example 2, we're going to try to write a rule using this a sub 1 and this common ratio, and then find the sixth term. I think you know how to do this. I think you know how to use a formula and substitute in values. I think you know how to determine what number is being multiplied by each time. So I'm going to give you a minute to try examples 1 and 2. Okay, how much are we multiplying by each time here? Good. So r equals 4. If it wasn't obvious, you know, if you didn't just have that in your head, 2 times 4 is 8. Say it was like 2 and then it said 6.5 and you thought, I don't know what to do here. If you want to figure out what number you multiplied by, what would you do with that 6.5 and 2? Say it again? So you could guess what it was, right? And then try it and see if you get the same thing. Yep. How else could you find out what number you multiplied by? Yes, Glory? Division, yeah. So, good morning. If I divide 8 by 2, that gets me 4, right? If I divide 32 by 8, that gets me 4. So, yes, if it's not obvious, you could divide, but you didn't have to here because you kind of knew that it was times 4. All right. Example 2, a geometric sequence has a first term, common ratio, and we're trying to find the sixth term. What part of the formula is the 6? It's the n, yeah. All right, so I'm using my formula with the a's. I'm going to try to find a sub 6. That means the sixth term. Good morning. Thank you. All right. Now, most of you just put this into Desmos and you were able to get an answer, but if we had to do this with order of operations, what would we do first? So, yeah, well, let's do the parentheses first. So we would get 3 times 4 to the 5. And then do we do multiplication or exponent next? Exponent. So then you would do the exponent and then you would multiply. Alec, what did you get? Anybody else get 3,072? Yeah? Okay. Questions on 1 and 2? Okay. In example 3, we have to find the first 5 terms. You could use the formula 5 times, but that might take you a minute. Think back, there was an easier way that we did this kind of problem with the arithmetic sequences. We found the first term, and in that one we found the D, and we used that to create the pattern. Compare this formula to the original formula and figure out which of these numbers is a sub 1, your first term, and which number is R. Do that first, and then see if you can list your first 5 terms. Okay? I'll give you a minute on that. You did. Morgan, what was the first term? Good. So, looking at the formula, we can line up this 2 with a sub 1, and then we know the first term's 2. And, Owen, what was the R? The R is 5. And it's the same thing. You can see that R is the one that gets the exponent. So the R is 5. So that means that the first term that I put here is 2. And then Blaine, what's next?
5.
So we're going to use the 5, right, to get the next term? So when we multiply by 5, what's your next term? 10. Good. And then? Good. So we're just using those numbers. It's a little bit of a shortcut, right? Sally, what's next? And the last one? Thank you. All right. So you could have used the rule 5 times, but this way was a little bit easier. All right, write the geometric sequence given the 4th term is 24 and the ratio is 2. What do we do with that 4th term? So Sally says we could divide it by 2. What do you think? If we divide it by 2, what does that give us? A third term? Okay. Say it again. Uh-huh. Okay. All right. So Sally and Sky are saying we can back up to try to find a sub 1. So we know the fourth term, right? So if we divide by 2, that will get us backwards 1 step. And that will get us to 12. And then we can divide by 2 again to get 6. And divide by 2 again to get that a sub 1 is 3. That was tricky, right? So now we know the first term, we should be able to write the rule. I'm going to use the formula, same formula up here. So a sub n equals, and I guess it doesn't really say if we're supposed to write the rule or the sequence, but I think we'll just write the rule. First term, 3 times the ratio to the n minus 1. All right, refocus. Somehow turning the paper made you lose your focus. Refocus. Why can't r equal 1? What would happen if r equaled 1? Yeah, you can't have 0 in the what? Denominator. Yeah. So algebra does this a lot, where they tell you what number your variable can't equal because you can't have a 0 in your denominator. So yes, r can't equal 1, but don't worry about that. I'm not about to give you an r value of 1. In example 4, use the sum formula to find the first 10 terms. So in the sum formula, we need to know a sub 1. What is a sub 1? Which number is a sub 1? 2. Yeah, I was hiding over here. What is r? 5. Good. R is 5 because we're multiplying by 5 each time. And we also need n. What is n in this case? 10, because it's 10 terms. Good. All right. So go ahead and figure out example 4. And if you are doing fine with that, then you can also do example 5. All right. Did you guys set your problem up the same way I did? This one? What's kind of interesting is that we know the answer is going to be positive because we're adding all positive answers, right? But the formula is giving us a negative over a negative. So it does turn out positive, but somewhere in the middle there, it was negative for a moment. So I used Desmos. Did you use Desmos? Desmos is a really good calculator just because it does order of operations, right? Is that 4 million? You're right. 4,882,812. Hello. What happened with you during SS?
Oh, my teacher didn't tell me.
No, your teacher said you weren't there.
Oh.
Okay, have a
Yeah,
seat. All right, example 5. Suppose you go to work at a company that pays 1 cent for the first day. I don't know about that. 2 cents for the second day, 4 cents for the third day, and so on. So each day your wages doubles. Your wage doubles. A rule is, okay, so they tell you a sub n equals 0.01 times 2 to the n minus 1. Would you want this job? Would you want this job? No. Not on day 1 for sure. But maybe it pays off over time. Let's see. So let's look at that. First day is 1 cent, right? And every day is doubling, so your R is 2. So what would your total income, guys, total income, does that mean that we're trying to find just the 10th day or all of the first 10 days? All of them, right? So do we need to use the A sub n or the S sub n? S sub n. So that would be sum. All right, so let's use S sub n. Oh, actually, it's right here, right? Well, no, actually, it's not there. S sub n. What was a sub 1? Yeah, 1 cent is a sub 1. That's your first day. And since your wage is doubling, how much is your R? R is 2. So R is 2, and then N. N should be 10. All right, so let's find out how much you earned altogether after 10 days. I think 2 to the 10 is pretty big, but 1 cent's pretty small. All right. So for 10 days work, we're getting $10.23. No, thank you. All right, let's figure out 20 days, okay? I should have put S sub 10 there. S sub 20. Whoa, what are you guys getting? That's a lot of money for 20 days of work. I think that kind of even averages out pretty well. So it looks like if you stick with this job, it might not be that bad.